Okay, this video is still part of section 7.2. This is the part where we're going to talk about rationalizing the denominator. So we've talked a lot about rationalizing the denominator in the fact that we can't have a root in the denominator, and what do you do to get rid of that root in the denominator. So we're going to review that concept because we've only talked about it in the cases of square roots. And so when you have a square root in the denominator, you multiply by exactly what you see because you're squaring a square root. So we're going to have to think about that inverse thing. So when you're rationalizing the denominator, what does that mean? It means to eliminate the radical in the denominator. It's okay to have a radical in the numerator. Whoops. You just can't have a radical in the denominator. Okay, so it means to eliminate the radical in the denominator. And so you do that by using inverses. So we are going to gather groups of the index. Right, now I know right now you're thinking that that doesn't make any sense, but let's try these examples and it will begin to make sense to you. So in the first example, we are dealing with a square root, okay? So to take things out from underneath a square root, you need to have two of them so that you can have a perfect square under a square root. So our goal is to have squares under the square root so they will cancel and we'll be left with just the variable, and that will then eliminate the root. That's what we're trying to do. So if we look at this particular problem, right now we have root 5xy. So I'm going to write that over here, 5xy. And we have 1, they're all raised to the first power. And so in order for all of those three things to come out from underneath that radical, I need to have two of them because it's a square root. So that means I need one more 5, and I need one more x, and I need one more y. And in the first section of this lesson, we learned the rule for multiplication. And it said that if the indexes were the same, then we could multiply the things together and consolidate them under one radical. So if I just go ahead and put a square root and I multiply these guys together, now I have the square root of, I have two of these, so I have a 5 squared, and I have two x's, so I have an x squared, and I have two y's, so I have a y squared. And I have created perfect squares under the square root, okay? They cancel, and I just have 5xy. That would be the denominator of that fraction, okay? So when you see a perfect square, when you see a square root, you're trying to create groups of 2, okay? So I'm going to multiply the denominator by the square root of 5xy, okay, because I want it to be 5 squared, x squared, and y squared underneath that radical. And I want it to be that way because they're perfect squares now, and I can take them out from underneath the radical. And I've eliminated the radical in the denominator, okay? But we all know the rule that if you multiply the denominator by something, you now have to multiply the numerator by it as well. You have to keep everything the same. So if I multiply my denominator by the square root of 5xy, I have to multiply my numerator by the square of 5xy, the square root of 5xy. So I'm going to now consolidate those under one radical. So I have 5, and now I have an x to the 4th, and I have a y. And so some of that will come out from under the radical. The 5 is only to the first power, and the y is only to the first power, so those have to stay under the radical. But remember, you can use that division rule. 4 divided by 2 is 2, so that's going to come out. And I'm left under my radical with the 5 and the y. So I want you to think about one thing, and that is simplification. So I told you that silly story about the soldiers outside of the castle and the queen within the castle. So we can't simplify anything underneath the radical. That has to stay there. But are there things outside of the radical that we could simplify? So can we reduce the number of soldiers in some way? And that is true for this. X squared divided by x is x. So in other words, if I take an x away here, I have to take 1 away here. And so that's going to simplify to x times the square root of 5y all over 5y. That is your final answer. We have rationalized the denominator. These are a little bit lengthy, but take your time and just kind of think about what you're doing, and you should be all set. Example 2 is a third root. So now what we're looking for are groups of 3 under the third root, because we want those to cancel and we want x by itself. Okay? So let's think about this. I'm going to do the reverse of the division property. So instead of putting them together under one radical the way they are now, I'm going to separate them. So I'm kind of doing that backwards. I'm going to do the third root of 2 over the third root of 3x. And I'm doing that because I need to figure out what I have to multiply that denominator by. And I know for certain it needs to be a third root, okay, because we only can combine the same kinds of roots together. And I know that I need groups of 3. I know I need 3 of them. So right now I have 1, 3. So that means I need 2 more. Okay? And I have 1x, and that means I need 2 more. So this is how you determine what you're going to multiply by. What kind of index do you have? This time it's a 3. Then you need to gather up 3 of everything. I have 1, 3 now, and I need 2 more. I have 1x now, and I need 2 more. That is going to mean that I have 3 3's, and I will have 3 x's, and I'll be able to take those out from under the radical. So remember that they cancel, and my denominator is going to say 3x. Okay? When you multiply the denominator by the third root of 3 squared x squared, you need to multiply the numerator by the third root of 3 squared x squared. Okay? Put these together all under one root, so I have the third root of, so I'm going to have a 2 times a 3 squared, and since I only have 1 2, and I only have 2 3 squareds, it doesn't do me any good to leave them stay separated, because they can't be simplified any further. So I might as well just simplify them and put them under the radical. I can't take them out. I don't have enough of them. So I might as well just consolidate them and make them nice and pretty under one radical. So 3 times 3 is 9, and 9 times 2 is 18. So I'm going to go 18x squared. Okay? And since there's nothing that I can remove from the 18 and the x squared, and since I no longer have a radical in my denominator, everything's just going to be finished. Okay, so there is our answer. We've eliminated the radical from the denominator. Okay, so in question number 2, I was looking for groups of 3 under my third root so that I could remove them. Okay, number 3 is just like it. It's groups of 3. If this was a fourth root, I'd be looking for groups of 4. If it was a fifth root, I'd be trying to get 5 of everything. So let's decide what we have to multiply by. I need a third root of something. I have 1 6. I need 2 more 6's to make a group of 3. I have 1x, so I need 2 more x's to make my group of 3. Okay, so if I consolidate those together under one radical, I have 6 to the third and x to the third, and both of those cancel, which gives me 6x for my denominator. Again, if I multiplied the denominator of my fraction by the third root of 6 squared x squared, I have to multiply my numerator by 6 squared and x squared. Okay, so let's consolidate under one radical. Right? So I need 6 squared, that's 36, and then I have to multiply that by 4. So I have 36, and I have to multiply by 4. Okay? Oh, no, yes, 36 multiplied by 4. So 144. So, oops, sorry, that's my marker. So the third root of 144, and the only x terms I have are here. So x squared. And then I need to decide, is there anything that I can break down? Okay, so I'm going to look at that square root of 144. I'm going to break down 144 over here and see, can I get any groups? So 12 times 12, 3 times 4, 4 times 3, 2 times 2, 2 times 2. So remember, I'm looking for groups of 3s. So there's one group of 3. There's a 2 left over, and a 3, and a 3. Okay? So, third root of 2 to the third times 3 squared times 2 times x squared. So the only thing coming out is this 2. So 2 third roots of 3 times 3 is 9. 9 times 2 is 18, x squared over 6x. So I've simplified, I've pulled out things that I can pull out. Now I just have to make sure that what's outside of the radical is simplified. 2 goes into 2 once. This is the soldier thing. And 2 goes into 6 3 times. So my final answer is the third root of 18x squared over 3x. And I've eliminated the radical from my denominator.